My mind is directed from reality, not made from a dream. This is find consecutive integers from a data stream. Okay. For a stream of integers, implement a data structure that checks if the last k integers parsed in the stream are equal to value. Okay, so you continue adding integers to the stream of integers, and you want to check that that stream of integers for at least the last k elements in that stream of integers are value. Okay. Initialize the object with an empty. Okay, so the data stream class has two functions. You have the initializer, where you're going to initialize with value and k. Initialize it with an empty integer stream and two integers, value and k. Okay, what do these values mean in the context of this problem? Okay, consecutive integer nums. It adds num to the stream of integers. It returns true if the last k integers are equal to value. Okay, so you're initially given the value that you want the last things to be equal to, and then k is how many in a row consecutively need to be equal to that thing. If the last k integer values equal value, then you return true. Otherwise, you return false. If there's less than k integers, then you just return false by default. Okay, so in this problem, I guess if we wanted to walk through how this works, we're going to use a value. We'll use a value equal to 4, and we'll have k equals 3. And I'm just pulling that from here, right? The first thing we add to our stream, so if we had this stream that we kept track of, right, the first element we add is 4. But we'll notice that there's not enough elements even in a row in order for our system to even be accurate, right? If there are less than k integers, the condition does not hold true. Okay, then we add another 4. Same situation here, right? We need at least 3 values added before we can even consider this condition. Then we add another 4. And the last 4 things are 4s. Therefore, right, the last 4 things are the value. Therefore, we return true. And then finally, we add 3, and 3 messes everything up. Right now, the last k things, right, the last 3 things are not 4, so we return false. So the easiest way to solve this problem, kind of the brute force approach, right, would be just to create a stream, add every value, and then check the k values before. Okay, so that means for each query, it's going to take k time, right? And we'd have to keep track of the last k data values. So we need k space. So it'd take k time for each query, k space total. It could take even more space if you just looked at every query. So if our constraints have it that, there's 10 to the 5 calls to consecutive, and k is less than or equal to 10 to 5. That means we have 10 to the 5 calls, and each 10 to the 5 calls is going to take k time, right? Because you're going to have to look at all the k previous items that you've added to your stream. So that's going to be 10 to the 10. There's no way that that's going to meet the complexity constraint. Maybe it will, but there's definitely a better solution than 10 to the 10, right? If I was reading this problem and someone told me, for every query it's going to take k time, I'd be very suspect, right? I'd be very suspect. I'd be very suspicious of that answer because, 10 to the 5, if k is less than or equal to 10 to the 5, you're going to do 10 to the 5 operations every time you do a query, and you have to do 10 to the 5 queries. That's 10 to the 10. I doubt that that's the optimal solution. So I guess the way to think about this problem, and there's a number of problems that are similar to this, but I guess the idea is, when we add this 3, right, that's what became the problem. The fact that we added a 3 made us lose the consistency of having a 4, okay? Now, for how long after we add this 3 is it going to create a problem in our solution, right? Because as soon as we add a 3, we no longer get all of the values equaling 4. So for how many iterations will that still be the case? Regardless, since k equals 3, right? So we have to look at the 3 previous things. Regardless of what's added here, this 3 is still going to create a problem, right? Regardless of what x is. If x is 4, it doesn't matter if x is the value we want, which is 4. It doesn't matter if x is 25, it doesn't matter what x is, this 3 is still going to be a problem, even though we didn't add it this iteration, right? And then when we add another element, we'll just call it y, right? Again, if y is 4, y is not a 4, this 3 is still going to be a problem, right? This 3 is still an issue, even though it's from 2 previous iterations. Why? Because this 3 is still in this k size window, right? We have this k size window of the k previous elements. And as long as that 3 is in that k size window, it's still going to create an issue, regardless of what x and y are, right? So all we really need to do is keep track of the most recent issue, right? Because the most recent issue is going to keep us from getting the k previous values equaling the value that we want, right? So what I'm basically saying is, like, how do I articulate this? This 3, the second I add this 3, it's going to be an issue for the next 3 iterations, right? As soon as I add this 3, it's going to be an issue for this iteration and this iteration and this iteration. But if something else comes along the way that also creates an issue, like another 3, or let's just say 2, now it's the case that this 2 is going to be an issue for the next 3 iterations. So I just need to keep track of the most recent thing that's causing problems, because that most recent thing will continue to cause problems until the most recent thing exceeds k, right? So how do I think about this in terms of maybe something more recognizable? I don't know. You know, if I can only relax in a store as long as there's no customers, right? Let's imagine you had a store where customers walk through and each customer took 20 minutes in your store, okay? And if the customer's not in the store, I'm just chilling there on my phone, and I want to be on my phone. So as soon as a customer walks in, right, as soon as the 3 enters the system, if the 3 is going to be in the system, or the customer's going to be in the system for 20 minutes, I know I'm going to have to wait at least 20 minutes from the point where I'm at right now. And then that customer will keep walking around the store. If another customer walks in while the previous customer is still in the store, I'm going to have to restart the clock. I'm going to have to wait another 20 minutes because this new customer is also going to take 20 minutes. And I can discard information about the previous customer, right? Whoever is the most recent person to enter the store is going to reset that clock, right? So basically for this thing, there's a clock size of 3. What I mean by that is, like, when I add this 3, there's going to be k equals 3 cases, right? 1, 2, 3, where that 3 is creating an issue. And as soon as 2 comes in, now I know I discard 3. The second I see 2, I don't need to worry about 3 anymore because 3 is on its way out. I got a newer person in the system, which is 2, who's going to be my, causing problems for the next 3 iterations. So you can think about these numbers coming in as being people, right? And if that person isn't the value I'm looking for, I'm going to know that for the next k values, this person's going to be creating a problem because this person's going to be in my window for the next k iterations. So let's walk through a problem at random. Now, to keep this issue, you don't really need to keep track of the actual stream itself. Just the most recent person that created an issue, right? If I had customers walking in, I only need to keep track of the most recent person who walked in because everyone who came in before them, regardless of the number of them, they're going to be gone before the most recent person walked in because they all stay the same amount of time. Okay, so let's say the value is 4 and k equals 3. Since I have nothing in my array, I could say my most recent issue. So we'll just call it problem. Right, the problem customer, or let's call it location. So this is going to be the location of the most recent issue. Well, since there's nothing in my array, the most recent issue is 0, right? Because I need there to be at least something. I need to at least have my array fully populated, right? Because if the array is not fully populated, right, if there are less than k integers, the condition doesn't hold. So the fact that there's nothing in my array is an issue in itself. So I need there to be at least location of the most recent problem needs to be at least 3 in order for me to say that this is true. So let's say the first value we add is 4. Okay, so we add a 4. So what would that mean? Well, the value 4 equals what I'm looking for. So that means now that I have a 4, my issue is 1 away. Right, if we think about this in terms of the window size. right? My most recent issue is this point here, and it's 1 away. So let's actually, so now location is 1 away. And let's say we added another 4. Now the location is 2 away. I'm just going to use the same color here. And then I added another 4. Now the location is 3 away. The location that's causing an issue is 3 away. So that means that this query would return true, right? This query would return true because there's no issue. There's no one inside my K window that's causing trouble. As soon as someone does enter my system that causes trouble, like here, now there's someone in my, what the hell? Now there's someone inside of my system that's causing issues. So since there's someone in my system who's causing issues, I have to restart this counter. I'd say, okay, now the location of this thing with respect to my window is 0, right? Because now there's a 3 here. So then when I add another 4, since I know that the location of this thing with respect to this K size window is still less than K, right? The value of location is still less than K. I know that I still have an issue here, right? And then again, right, if I added another 4, it's still the same thing, because even though the newest thing isn't going to cause trouble, it's still not it's still not outside of my window, right? Now when I have another 4, and this just keeps going on and on and on and on like this. Now this is size 3, right? So when it's 3, I get it. When it's greater or equal to 3, right? When it's greater than or equal to my window size, I get a point. And then just so we can see kind of the other case, let's imagine we added 2. Now when we add a 2, what happens? Okay, now there's something, the most recent thing that's causing me trouble is this 2. Right, this 2 is causing me trouble. So now I have to set this back to 0. Now it's getting really messy. Set this back to 0. And then what if I have another 2? So here's the issue of the most recent customer. So a customer just walked in with 2, but now I don't need to worry about them, right? Because whatever issue I had before, right, that's doesn't matter anymore, because I still have to wait. Whatever issue I had before will take less time to resolve itself than the new issue that I'm adding, right? Which is this new 2. So that means that this doesn't increment to 1, it stays at 0, right? Because I'm encountering a new person which is causing issue, right? Because now, no matter if I add 4 and 4 and 4, not until I get to this point will it resolve itself. So basically the idea here is you create a sliding window idea of size, of using K previous integers, but you don't need to actually keep track of the sliding window. Just keep track of the most recent thing that's causing an issue, right? We only need to keep track of this information here. And if it's greater than or equal to 3, right, if it's greater than or equal to K, we know that there's no element in our sliding window that's causing trouble. Every time we encounter an element that's causing trouble, we reset the size of location to 0, right? Everything's going good. We encounter something that's causing trouble, we have to set it back to 0. Because we know that we're basically restarting this counter, right? Every time someone walks in the store, I know I'm gonna have to wait another K time before the store is empty, because everyone spends the same amount of time in the store. Maybe that's not the best idea, but hopefully that makes sense. So we should definitely keep track of the value, right? We should keep track of K. And then we know that the location will equal 0 when we begin. And then what we do for each number. So we say, well, if the number doesn't equal the value, right? So that means that we're looking at a number, and this number isn't the value that we want to see. So this number is going to create an issue. This number is going to force us to return false, right? Because it's going to break the consecutive solution, right? Because there won't be any more consecutive, because the newest thing isn't the consecutive value we're looking for. So it doesn't equal the value. We're going to know, okay, now we have to restart location. Right, just like we did here, right? Everything was going good. This got populated to 3, and then as soon as we saw this 2, we had to set it back to 0. Otherwise, we know, okay, we haven't seen something that's going to create an issue, so we can just update the location of the most recent thing that's causing an issue, right? Because every time you add a new number, if the new number doesn't create an issue, the old thing that did create an issue will get moved over 1. And then all you have to do is say, well, we need, if the location of the most recent thing, right, we have to return that it's greater than or equal to k, right? Because k is the size of our window. So the location of the most recent thing that's causing an issue needs to be outside of the range of k, right? Basically what this is saying is like, if there's a person coming in, right? If there's somebody coming in, I know I'm going to have to wait k time for them to finish. If nobody comes in at this minute, I know I can wait another minute. I mean, that I know that the most recent person has been here another minute. And if the most recent person has been in here greater than or equal to k time, that means they're going to leave. Hopefully that makes a little bit of sense. Let's go ahead and submit that. No. Oh, okay. I don't know why I did self.k not equal that. Just self.k equal k. Come on. Okay. So what's the runtime of this whole thing, the space? Well, for space is constant, right? Because, we just create 3 variables. I guess you have to create variables based on the values, right? So you can say, oh, it's log n because there's log n bits in each of these data points. So you have to say that information. I'm not going to play that game. I'm just going to say it's constant. Okay, so for space, it's definitely O of 1. What about time? Well, I populate these 3 variables. That's constant. For each consecutive call, I just do 3 checks, right? I don't go k back. I just ask 3 simple questions. It's a constant question. It's a constant question. And it's a constant question. These are all constant statements. 3 constant statements is constant. So this is a constant operation. But so this function, right? Both these functions are constant time, constant space. But you're going to make 10 to the 5 calls to consec, which is bounded to k. So it's the whole thing runs in big O of k time, right? Because I'm going to make at most k calls to this function, right? This is going to be 1 call, and then I'm going to make at most k calls to this. So it's at most k time. But these functions themselves are constant. So if you were in an interview, make sure you articulate that, right? Be like, this whole procedure of you calling these things, that's going to be O of k. But the functions themselves are constant. Okay, so always good to articulate things that make your interviewer know that you're aware of, the context. Context is key, always. All right, guys. Peace.